now. The goal of the demo is not to show you how to win that competition, because you cannot. It almost ended. So the real life scenario is, it was posted there, the dataset was posted there by Japanese company, so full credit goes to them. There is the goal is to predict who will buy coupons, because the test set is the coupons that were introduced in some particular week. Then you have to actually predict based on the training set which coupons will be actually bought, and then the system scores you. So I'm going to show you like the first piece, how do you actually plug the data into Spark and analyze it with a tool set available. So the tool set we will use is first of all Spark. It's for data pre-processing, machine learning. Then for charting and exploration, there is Matplotlib, and more nice libraries called Seaborn, which also uses Matplotlib, but provides, let's say, a better interface and better charts. So of course Python, and then Jupyter is a notebook. Again, is a notebook interface, and sometimes called IPython. So people talk at this conference a lot about IPython, and this we will run all this in a IBM tool which is in beta. It's called Data Scientist Workbench, which allows you basically to run IPython notebooks in the cloud. Let me show you. So this is how the tool looks like. So it's not a surprise for people who actually worked with Jupyter, with IPython before. The only difference here that you have on the right, you have this like a sidebar with things that you just drag and drop there. It's designed for just data scientists who don't want to deal with anything like data load and stuff. So I just drag and drop my Python notebooks here. Actually, I developed them here. And data you just drag and drop here. So this is it. I'm going to remove that. So it starts all with initializing Spark context. So you see that it's already initialized. You have Spark version, it's 1.4.1. So then I'm going to import some libraries. And the first problem we are going to deal with is how to read the CSV file. For CSV file, there are multiple libraries available. So there is a Spark packages site where you can download CSV. You can come up with something handmade like this. So this is something I came up with myself. And then there is a Databricks library that developed in Java, which is sometimes hard to plug into things if they run in cloud. So here, for example, I cannot reinitialize the context, so I couldn't plug it here. Had to develop it myself, right? So then you read the CSV, you get the data set, for which you can see the schema. You see here that actually I have to deal with types, right? So here all the types I have are string, and this is the problem. But you can also see the data set right away, so you can browse what your data is. And two things here at this point. First, this is a nice tip and trick for you who actually want to visualize, quickly look at the data, because if the data set is big, and you have here actually read it in a Spark data frame. So if you put that whole data frame on top of you, that's gonna take a lot of memory. Then your system probably will fail. If you are going to just run command head, it's not gonna look like as nice as that. It's not gonna show you this nice table right here. So the trick I'm using is like I'm limiting to 5 rows, which means it will only read 5 rows from the table. Then I convert it to pandas, and pandas is showing you these nice tables. Then I'm using some other approach. So you see I download here some CSV actually library from the Spark packages. Actually, I had to fix it in the process of doing this demo a little bit because it was too slow to work with when the data set is kind of big. And a little bit about the data set at this point. So the data set is basically a large table or large CSV file saying, showing basically who visited the coupon purchase site and who bought anything at any particular page. So we are just going to reduce that to a really small data set, saying who just purchased the site with the properties of the people who purchased, who did the purchases. So there are just 3 tables more or less, so this is the large one, and there are 2 more. One is describing user attributes and one is describing coupon attributes. So, so we will just, I read these 3 tables from CSV, so I will just register them as a table. Then actually I'm an SQL guy more or less, so I'm not a Java Python programmer on a serious level, so I'm better with SQL. So here's what I do. I just query these data sets and actually make some aggregates with them. And again, I'm using the same trick. So after I did some SQL query, this is actually the step I took to reduce this data set drastically. So now I have something really small to work with, which is just aggregated purchases to coupon and user. So you see here, previously I had something like 2.5 million records, so now I have just 170K, 7K. Then I actually run another thing that is aggregating that all together, calculating some I don't know, some stuff. So for example, how many times it was purchased, what's the average price, what's the average price rate, and so on and so forth. Then I am looking at this table again, and then I am trying to understand something about the data, right? So I am trying to visualize and plot things after I aggregated it. And actually, I'm going to save the temporary results in on the system so that I don't have to run this aggregate again if I can restart this notebook. There you see that, for example, one of the things I want to know is what are the purchases by region, right? So here, this is Japan regions, and I see that, you know, Tokyo, of course, no surprise, leads here. So I want to also present it as a bar chart with seaborne library. So there is a horizontal bar chart that says, indeed, Tokyo is the leading region in coupon purchases. Then I want to analyze it a little bit differently. So I want to analyze who is. I want to see, for example, is that the case? You know, that men and women are buying different things, different kind of coupons, and I see that there is almost no difference. So the profile for actually men and women are the same. So they are probably some buying a little bit more of Japanese hotel, but otherwise it's more or less the same profile, right? And I can also put it on a picture like this. So you see here I have that one split. Unfortunately, resolution doesn't allow me to show that. So much of a trouble. It doesn't allow me to show you that whole chart, but it's actually showing the females and males on the same plot and their amount of purchases by the type of coupon. So then I'm going to have another type of analysis. I would like to see, I would like to understand, you know, how frequently people buy on a particular day of week, right? So I wanna plot actually a heat map of purchases by year and by the day of week. And I see actually that there is some pattern, but I don't understand this pattern completely, right? So on some months, for example, the Tuesday is dominant. On some months, the Monday is dominant. Probably it's related to something I don't understand. And then from there, we can actually build the detailed set with also SQL. And actually, that's going to be used to build the model later on. That was it, because I just wanted to show you just pre-processing and exploration, how it is done to prepare that for statistical analysis later on. How much time do I have? 20. Yeah, so the other demo I want to show you is related to IBM connected cars concept. So we have also a demo and also an infrastructure running on also in cloud on Bluemix that can serve and actually demoing the scenario of connected cars. Just give me a second. Just let me group together a little bit. I will just open another notebook here. So this is a related scenario, but not exactly the connected cars scenario. So we have also at the booth, you can see what the connected car scenario looks like. But here the scenario is to actually analyze data to understand how distracted driving affects the speed. So we have data set, which is a data from the different devices placed in the cars. Then we have speed, and then we have flag that says actually if the guy got the call during the driving. So we use that whole scenario to build a predictive model in the end, and to understand, for example, here we have speed versus phone activity. So how it is correlated, we see that indeed it is correlated so much. So we can actually calculate all sorts of things, and then we use this MLE clustering k-means model to group these things together. And then we train the model, then we save it we actually save this data set for later use. And this is always the examples. It was the goal was, like I said, to show you a little bit how do you get around the tool if you are doing some analysis work with it. And probably for a lot of you it was nothing new. Probably there are people in the audience who are much more advanced as me. The goal was to introduce people to the tool. Now I am going to hand mic to Frank, who will talk about system ML.